Thank you very much. Okay, so a little about me. I'm a Kubernetes user for 4 days, so this could be a complete disaster, or it could go well, you never know. You guys probably have a lot more experience about it than me. I'm currently technical product manager of NGINX. There's kind of only one of me in the product management department. It means I get to play with cool hardware and work with partners and things like that. So it's really cool. Before that, I worked at HP on, I was the lead developer of our load balancer as a service, which was called OpenStack Libre, or StackForge Libre back then, which is now, I believe, it's Octavia, I think it's called now, something like that, which is spun off of my work there. And I worked at the Advanced Technology Group for a little bit as well. And I've also worked on several open source databases, including MySQL, Drizzle, Rackspace, and I'm alopecia sufferer, as you can tell by that photo. My hair falls out a lot. It's happening right now. Okay, so the goals of today's talk. I'm going to talk you through very basic and some a little bit of advanced load balancing features. The current load balancing options inside Kubernetes. The Ingress resource in particular is what I'm going to be focusing on. And we've implemented a couple of Ingress controllers for Nginx, which I'm going to hopefully demo. I'm going to chicken out a little bit and actually use a demo video because I've had demos that have knocked out the entire Wi-Fi for a conference before, and I really don't want to be doing that again. So the basics of load balancing. There are really two reasons why you're going to want to set up a load balancer. One is for high availability, in case a web server blows up, and it happens, unfortunately. And the second is load distribution. You don't want your server hitting 100% CPU or over 100% CPU and delaying all the requests. You want pretty fast responses. So two basic types of load balancing we're going to be focusing on here. First is layer 7, which is HTTP load balancing. Essentially, load balancing based on the actual request, the headers, the actual URL, etc. And layer 4 load balancing, which is load balancing the TCP and UDP packets. So as far as advanced load balancing goes, there's different things load balancers can do, such as SSL termination. It can do active health checks based on various parts of the server. It can check to make sure the data is correct and just ping to make sure the server's fine. You've got server security, such as authentication, rate limiting for DDoS protection. In some advanced load balancers also have web application firewalls. Session persistence, it can be important if you don't want the user logged out on every single request, and I have seen that happen on certain websites. Content-based routing, so header information, request. If you want to access a PHP file, make sure the request actually goes to a PHP server, etc. And many more things. So as far as load balancing in Kubernetes goes, there's really internal, which is kubeproxy, and external, which there are several different variants available: node port, load balancer, external IP, service load balancer, and Ingress. And I'll focus more on Ingress in particular. So kubeproxy, you probably already know about, but every service gets an internal IP. And they can get the your application can get the IP from an environment variable or DNS, and that's basically how you set it up. And this is basically what it looks like in a kind of cartoonish diagram. I didn't draw it. There's a 3-node cluster with a service called B, and the black pod there is sending requests to that service, and kubeproxy is the load balancer for those requests. It supports TCP and UDP, I believe. It has health checks using liveness probes, which can be shell scripts executed in a container of the pod, or HTTP requests. And you can do some form of client IP session affinity, which basically means you can hit the same pod every single time. So as far as external goes, the first option is node port. It essentially exposes the kubeproxy port to the internet, and typically it's on a very high port in the 30,000s range, I believe. It has the basic same features as kubeproxy, but session affinity is a little bit difficult because it needs to hit the same node every time, and that doesn't always work out that way. So next up, there is the load balancer service, which talks directly to the host cloud service and provides the load balancer. So for AWS, it talks to ELB. For Google Cloud, they have their own load balancer system. It typically uses the cloud's load balancer server to send requests to node port. So it's kind of an extra layer on top of node port usually. And it's TCP only. It's IP Infinity, client session Infinity in Google Cloud. And it does support some form of health checks. Unfortunately, I don't know the details of that one. And next up, there is external IPs. So it's another way of exposing kubeproxy to the outside world. This time by assigning a public IP to the server. I believe in Google Cloud, it actually shows as internal IP, even if it's external, but never mind. And there's similar limitations as to node ports. It's TCP, UDP only, and it can do health checks, but affinity is kind of the same problem as node port. And you could use round-robin DNS to kind of pseudo load balance between them. So next up is service load balancer. This is in the contrib repository for Kubernetes. It's an HA proxy-based load balancer service that spins up pods and configures them appropriately. You can do TCP, UDP, URL mapping, SSL termination, session persistence, and various algorithms, which you could do via annotations in the YAML configuration file. And you can see here that you would map it so that your service A goes to /service A, your service B goes to /service B, and so on the URL paths. Which leads me to the next thing, which is Ingress. And this was unfortunately started before the Ingress project. It's new in Kubernetes 1.1 as a beta feature. And it defines configuration for an external load balancer. In this example, you can see that the path is configured to talk to a back-end service A and B. So if you go to hello.example.com/A, you'll hit a service called backend A on port 80. And it's configured there. And then path B is configured to talk to backend B on port 8080, which results there. And in version 1.2, which I don't believe is released yet, later this month, okay, they are adding a TLS support using secret files. So you can configure your SSL certs using, I wouldn't recommend doing it in base 64 or in opaque, but you could, in theory, do that. And then tell the Ingress server, I can't actually see from here, there we are, secret name, hello secret, and it will use that SSL certificate for the host hello.example.com. So it supports HTTP load balancing, SSL termination, which is really important, content-based routing, but you need to deploy a Ingress controller to make it work. So the Ingress controller watches various Ingress resources and configures the load balancer appropriately, whether it be a hardware or software load balancer. So in the contrib repo of Kubernetes at the moment, there are a few various options you can use to configure a load balancer. There is the Google Cloud Controller, which is pretty well baked at the moment, I believe. There is NGINX Alpha, which is a basic proof of concept for implementing controller in NGINX. I believe it doesn't actually use most of the features of the Ingress controller. And there's NGINX Third Party, which is a much more extensive controller with SSL and TCP support. But it does require NGINX to have the Lua module installed to make it work. So a little bit about Nginx. You guys probably all know us as a web server or a reverse proxy. We do load balancing as well. Layer 4 and Layer 7, we've just added UDP support. I don't believe it's actually hit the commercial version yet, but it's in the open source version now. There's advanced algorithms, SSL termination, there's all the sweet stuff there. HTTP2 termination we can do now. Logging security, and in Nginx Plus you get a few extra features such as real-time statistics, layer 7 session persistence, dynamic reconfiguration, so you can send REST-based requests to the NGINX Plus server to add or remove various backends. And also they pay me to do cool stuff like causing a 40 gigabit network card to overheat, which I've done recently. Okay, so Michael Pleshakov, I apologize for mispronouncing his name, is a guy in our San Francisco office who made our own Ingress controller. And in fact, he made two of them, one for Nginx open source and one for Nginx Plus. And he also wrote most of this talk, so this is why I'm having to refer to notes quite a lot, unfortunately. As you can see here, it converts the Ingress configuration to an Nginx configuration. So here we have hello.example.com with path A going to backend A and path B going to backend B. And if you've ever read and my screen has gone. There we go. If you've ever read Nginx configurations before, you can see that the server defines the server and location defines different paths on that server. Proxy paths tells it which backend to speak to. So backend A, which is configured up here with a server IP address, and backend B is configured here with a server IP address. And my screen has gone again. Okay. So the Nginx Ingress controller watches for Ingress resources, watches services and endpoints to get an IP address of the service. This is mostly for the open source version, and because for the commercial version we can actually use the DNS, but I'll get to that in a little bit. And it watches for changes in the secrets files. So basically all these changes here affect the ingress, and it regenerates the configuration for Nginx and reloads Nginx. That doesn't actually drop any current connections when you reload Nginx. It's got a nice way of kind of bleeding off connections off of one daemon and kind of getting the new connections on the new daemon while it's doing a reload. So for Nginx Plus, we support re-resolving DNS names every X seconds. I'm not quite sure what it's configured to do, but it's pretty quick on our Ingress controller. But for the open source version, we only do DNS resolving on the first startup of Nginx. So we have to kind of re-resolve we have to set IP addresses for the backends on the Nginx open source version. There's no need to watch for services with and endpoints with Nginx Plus. This means it makes the implementation a lot easier. We actually took the Google Cloud HTTP load balancer as an example of how to write one. It's been written in Go, obviously, to make it work well with Kubernetes. As I said, there are two implementations, one for Nginx OSS and one for Nginx Plus. And it's deployed in the same container as Nginx, so the container starts and then launches the Nginx daemon. So there are various features in our controller. We don't support every feature yet. We're trying to work on that right now. So we support the HTTP load balancing, SSL termination, and content-based routing. In theory, you could add all these other features here by modifying the templates. And in the future, we want to be able to make it so you can just configure these with a basic YAML file. What if I put here? For Nginx to do all the load balancing, the service should be headless. Otherwise, the kubeproxy will actually take over from the load balancing side of things, which isn't always what you want. So for our demo that I'm going to be doing, we have tea and coffee services. Coffee is going to be a headless service, just to demo the difference between having it headless and not headless. Unfortunately, with neither of them, I could implement error code 418. I'm a teapot. I really wanted to do that, but wasn't able to. So tea and coffee are going to start with two replicas. There's going to be a secret file that's base 64. It's not encrypted, but Yeah, can't have everything. Cafe Ingress, which is going to define the paths to coffee and tea, as well as which secret file to use. The demo was running in Google Cloud, but as I said before, I've been burned with demos, so it's going to be a video that I'm going to pause and resume. The demo is running based on a GitHub master branch of Kubernetes from, I think it was the checkout was Monday or Tuesday. Okay, now let's seamlessly-ish switch to the video. Okay, so first we're going to look at the contents of the YAML files. This is the T replication controller, which is pretty simple. Should be pretty familiar with that if you've done these kind of things before, but it's using the NGINX demo Docker image. And this is the service for the T. And again, it's pretty simple. And the coffee replication controller, again, is pretty simple. It's almost identical to the T one. And the coffee service is where we've done things a little bit differently. So you can see here we've set cluster IP to none, which makes this a headless service. So every instance of the service is going to have its own IP address, and this is going to be important later. And I should have made this pause less. The cafe secrets file is base64 encoded for the SSL certificate and key with really long base64 strings. Next up is Cafe Ingress, which you can see setting up the secret file. cafe.example.com is going to be our domain name, with the path T to going to the T service and the path coffee going to the coffee service. Both going to be port 80. And the Nginx Plus ingress file. This is going to be using the Nginx Plus controller that I was talking about. The main points here is we're going to have 3 ports, port 80, 443, and 8080. And the 8080 is going to be for the Nginx dashboard, which I will also show you shortly. It's currently a custom image based on the Git repository, which I'll get to at the end of the talk. So we're going to currently load these into Kubernetes one by one. If I can type it correctly. And next up, we're going to get a list of the pods to make sure it's all running, and we can use this to actually find out which pod the Nginx, which server, in fact, the Nginx is running on. And in fact, we can see here it's Minion 99C4. So we're going to check the logs of this, and it will show us the actual Nginx configuration that was generated based on the ingress. So we can see here a big long thing spat out here. Pause it here. So because I'm using the plus, it can do domain name resolving like this. The SSL certificate has been supplied here. And we've got our tea and coffee locations. Switch over to the Nginx dashboard. This is what an Nginx dashboard looks like in Nginx Plus with the Upstreams tab. And you can see here that Cafe Ingress has just one element there, and that is the kube proxy. And then Cafe Ingress Coffee has two IP addresses there that it's got because it's in headless mode. And it's got that from the DNS resolving. So we switch over to T, and it's saying which host name and IP address it's coming from. I'll refresh a few times. You can see here it's changing between the two T web servers. And again, coffee, refreshing, it's switching between the two servers. And you see here we're using HTTPS to actually access them. So now we want to scale it, and I'm going to scale both of them up to 4 pods, I believe. And you can see here on the Nginx Plus dashboard that we now have 4 backends here. These bottom 2 haven't had any requests yet. And we still have one here on the T service because, again, that's still using kubeproxy. Switch over to the T service, and we're cycling between 4 different ones now on a kind of round-robin fashion. And again, this is on the coffee service. I'm switching between the 4 different servers. And wait. And that's it for the demo. So I'm going to select and switch back over. Okay, so in a tech preview, there's still quite a few features missing, and there's a few bugs, such as I had a problem where it was fighting with Google Cloud's L7 Ingress controller, and that kept overwriting the Nginx configuration and breaking things. So I had to actually manually disable that in my example. We want to expose more Nginx features, such as using annotations and config maps. We hope to actually have this ready by the time I gave this presentation, but it's not quite ready yet. We want to make it production ready and improve it based on your feedback. I think actually Michael did a fantastic job because he's only done this in about 3 weeks or something. So getting all this together in a short time has been great. So that's it from me. Resources including how to get hold of our Ingress controllers can be found at tiny.cc/NGINX Ingress. If you want to find out more about Nginx and in particular Nginx Plus, you can go to https://www.nginx.com. My site is linuxjedi.co.uk. On Twitter, I'm linuxjedi. Freenode, I can be found using nickname linuxjedi. There's a kind of running theme here. My email address is linuxjedi@nginx.com. Okay, so is there any questions that I probably won't be able to answer? Do you want the question was, when do you see using headless mode rather than clustered mode? And I see using, if you want Nginx itself to actually do the load balancing, so if you want to use various different algorithms supplied by Nginx, then you're going to have to use the headless mode. Otherwise, kubeproxy is going to be doing the load balancing part of things. You still get the SSL termination and things like that from Nginx, but if you want Nginx itself to do load balancing, you're going to have to use headless mode. I agree. The question was, why do you want kubeproxy in the first place? It doesn't make sense it being there, and I completely agree. Yes. I don't have an answer to that, I just completely agree. Anyone else? Yes. I don't actually know if that it should work. I would have thought it certainly that kind of thing would work with Nginx open source. That's a kind of question I'd have to go to Michael, unfortunately. That would be a very useful feature, though, I believe. Yes. In theory, you should be able to run 2, 3, whatever, and then you probably want to use DNS round robin or something like that in front of them. I haven't tried it, but I can't see why it wouldn't work. Anyone else? Well, my monitor crapped out a good time. That's about it. Thank you very much, everyone. If you have any questions or if you want any stickers, come to me. Anyway, thank you.